In this video, I will be building a 7408 series AND gate using basic components: the transistor, resistor, and the diode. So please join me. The main building block for our home brew logic gates will be the standard bipolar junction NPN transistor. The basic concept of the NPN transistor is that it will act like a valve, where applying a small amount of current at the base terminal will allow current to flow between the collector and emitter terminals. A transistor can be used as a switch or as an amplifier, where increasing the current at the base allows greater current flow through the collector-emitter path. We can take advantage of this property and can use it to build Boolean logic gates from transistors. In this example, we will create a simple logic AND gate by chaining the emitter of one transistor to the collector of a second transistor. If we close only one switch, allowing voltage to a single base terminal, thus opening the valve of either but not both transistors, the circuit will remain in the logical off state, as one transistor will always be a blocker. Only by applying voltage to both A and B inputs will both valves open and current will flow through the entire circuit. I've converted the previous simple diagram into an LTSpice circuit. For resistor values, I am using 100 kiloohm. For transistor type, I am using a BC547B. I have replaced the buttons in the simulation with two out-of-phase sine waves to emulate buttons being pushed at various times. I'm feeding a 5 volts into the circuit, into the transistor circuit, and the output is where we will put our LED. Here is the breadboard implementation of that circuit. You can see the primary circuit is the same, the two transistors with voltage coming in the collector, exiting out the emitter into the collector of transistor number 2. We've added some buttons with pull-down resistors. So let's see how it works. I'm going to push button number 1, no output. Press button number 2, no output. Press the combinations of button number 1 and number 2, and you can see the AND gate works. Let us see how our simple transistor AND gate compares to the operation of an actual 7408 IC. In order to make this comparison, I have removed the manual push buttons and replaced them with inputs that I will drive with my dual channel waveform generator, demonstrating the use of offset sine waves to generate the test signal. Additionally, I have added an actual 7408 IC so that we can compare the output of my simple logic gate with that of the actual component. I will use my dual channel arbitrary waveform generator to generate sine wave signals, using them to help us visualize the correlation between input and output voltage levels. The yellow and light blue signals represent the two input voltages over time. The lavender output level on channel 3 is the resulting output. Now we use the fourth channel, which is measuring the output of the actual 7408 IC. On the fourth channel, notice how the rising and falling edges are sharp, representing distinct on and off states, whereas our homebrew AND gate on channel 3 shows a correlation between input and output levels. This should be expected, as the current circuit is acting as a valve, and the output voltage is a function of the two input voltages. Our homebrew AND gate functions perfectly as a demonstration of transistors and Boolean logic. However, would not work at all as a component of a high-speed digital computer. So much for my plans on saving money by designing my own i7 processor from components laying around my lab. So what do we do if we are not quite ready to throw in the towel on our plans for semiconductor industry domination? Luckily for us, in the early days of electronics, companies used to provide actual technical documentation for their products. Many times this even included schematics. So if we want a clue as to what makes a 74 series IC function, we need to look no further than some of the older data sheets like this one from Texas Instruments in the early 1980s for their 7408 series IC. I will take this schematic and convert it into an LTSpice circuit. I have made my simulation circuits as close as possible to the real schematic while using component values that I had on hand. I will of course provide links to the circuit documentation in my GitHub repository. From Texas Instruments schematic to LTSpice circuit, and finally to breadboard circuit, here is my attempt to replicate TI's 74 series logic using discrete transistors, resistors, and diodes, as described in the intro. I've hooked up the homebrew transistor AND gate to the oscilloscope with the signal generator. Again, feeding the A and B inputs. The A input is fed in at 1 Hertz. The B input is fed in at 2 Hertz. And it has a phase offset of 180 degrees. That way we get some non-overlapping input triggers. So let's go ahead and look what the input waves look like. And now let's go ahead and bring in the signal from the AND gate output. This is the transistor homebrew AND gate. As you can see, we are now getting some very sharp triggers on and off. And let's go ahead and overlay that with the output of a 74 HCT08 AND gate from Texas Instruments and see how it compares. All right. So the purple is our homebrew AND gate, and the blue is the Texas Instruments AND gate. It does appear that our new AND gate performs much closer to the actual IC. The Texas Instruments IC triggers at a little higher input voltage, approximately 2 volts to our AND gate at around 1.6 volt, and also shows about 1 volt higher output at around 5.2 volts compared to our homebrew transistor at approximately 4.4 volts. Although our AND gate may slightly miss TTL specs, I will still lower the bar to consider it a success. So if you do not currently have a home electronics lab or access to electronics components and test equipment, you are not out of luck. Thanks to circuit simulation software such as LTSpice and other similar software, you can create circuits with thousands of logical components, including the transistors, resistors, diodes, and power sources used in designing and testing my example circuits. I will now demonstrate. Using my example circuit for the simple AND logic, I will run a simulation. I am adding logical oscilloscope probes to the same points in the diagram that I used with my Rigol in my actual physical circuit. Then, as a comparison, I will overlay the simulated circuit to my actual oscilloscope screenshot. Notice how the lavender colored output curve from the oscilloscope trace of my actual circuit are accurately represented by the simulation. Likewise, I was able to accurately simulate the more complex 7408 circuit. To recap, there are many simple examples for creating Boolean logic gates using basic building block components such as transistors and relays. But if you are willing to do a bit of work broadening your searches, you can find many examples and schematics that can help you delve deeper into understanding digital electronics. As an amateur hobbyist, I enjoy continually expanding my knowledge of digital electronics, and I have found that there is a tremendous amount of interesting information in datasheets. Learning increasingly lower level of component technology helps me to better understand the complex systems that are created with those technologies. LTSpice is a great way to play with circuit components before attempting breadboarding. I will provide links to the LTSpice simulation software used, as well as the circuit designs in LTSpice format that I have on my GitHub page. I hope this video was of interest to you, and I thank you for watching.